Okay, yeah, so I'm Jordan. Hi, everyone. And Anika kind of started reading this, but just so we get it all out there, the title of my project is Evaluation of an Open Source Geodetic Community Python Package to Support the UNAPCO Archive Cloud Lift. And I know it's a really wordy title. I promise I'm going to go into the nitty gritty of what that means as we go. All right, so my internship kind of has two types of goals. So on one side, I had my actual project, my actual contribution to UNAVCO to work on this code, which I'll talk more about throughout the presentation. And then on the other side, I had these professional development goals. So I just finished my undergrad. I am actually about to start a job where I'll be working on satellite data processing, coincidentally, actually. So learning about the GNSS domain this summer was huge for me, as well as just kind of various software skills that I'll need in that job, kind of specifically like Python related skills. And then I also wanted to explore just kind of how I, as a math and computer science person, can fit into the earth science community. So getting to explore various career paths was also really important to me this summer. All right, so getting into my project, a little bit of background is that UNAVCO is currently in the process of transitioning from on-premises GNSS data archive to the cloud. So a little bit more about what that means is these on-premises data stores are RINEX files. They're basically the standard file type for GNSS data. And I'll talk throughout this presentation about different types of RINEX files, RINEX 2 and 3. Basically, those are just different versions of RINEX files. RINEX 3 is bigger, contains more information, essentially. And we can't just pick these RINEX files up and put them in the cloud because RINEX files are not cloud optimized. So there needs to be some sort of data format conversion before we can go to the cloud. So that's where GeoRINEX comes in. GeoRINEX is an open source, meaning anyone can contribute to it, use it, work with it, software package that is designed for RINEX to cloud optimized data format conversion. So the way this works is the RINEX file is loaded into GeoRINEX into what's called an Xarray data set. So Xarray is a Python package, and these data sets are essentially labeled databases in memory, and they really closely resemble netcdf files, which are a analysis ready and can be cloud optimized data format. So this is the process. RINEX file gets loaded into a data set using GeoRINEX and then can really quickly be exported to netcdf. So where my project comes in, GeoRINEX is really slow for loading RINEX 3 files specifically, which is an issue because RINEX 3 is becoming more and more popular. UNAVCO is collecting RINEX 3 files every day. So that has to be sorted out. So my job this summer was to determine exactly how slow this is and why it's taking so long so that it can be fixed. Slides for this. So, sorry, everyone, we'll get there. So I did this through profiling. Profiling is essentially collecting data on what happens when your code runs. And I essentially took 10 RINEX files, half of them were RINEX 2, half of them were RINEX 3, and used this really popular profiler called cProfile. Using it just looks like this code here. It's pretty simple, just to collect some data and figure out what's happening. So when you run cProfile, you get tabular data, you get a bunch of numbers, and that's helpful. I did get a lot of information from that, but I wasn't getting the full picture until Ted Haberman introduced me to this other Python tool called SnakeViz, which is really cool. So you can take your profile results and use this other package to generate this interactive visual of your profile results, which is what I'm showing you here, because I think it's a little more descriptive than a giant CSV file. Yeah, and so I won't get too into the nitty gritty unless anyone wants to hear about it later, but yeah, essentially this gives you how long each function called within this load process takes. So the length of the bar tells you how long the function takes, and then subsequent bars are subfunctions. So here, Rhinex obs is a subfunction of load, meaning it's called within this load function. So just some like quick, really key findings from those results. Rhinex 3 files took on average about 37 minutes to load, while Rhinex 2 files took around 23 seconds. So 37 minutes is just too slow. It's not going to work for this big cloud lift that UNAPCO is trying to do. And it seems like merge, which you'll see here, which is an X-array function. It's how this data set is being put together, is the big time consumer for Rhinex 3 loads. It's actually about 90% of the overall load time is happening within merge and its subfunctions. So that's definitely what we need to look at. Another interesting finding was that I experimented with just loading one constellation from each file, so just loading the GPS constellation in this case. And one thing you'll notice is that if you remember what that other figure looked like, up until this epoch function, it looks pretty similar. It's load Rhinex odds 3 epoch. But then instead of merge here, we now have concat, which is another X-array function that functions kind of similarly. It's compiling that data set, but it's a lot quicker because it has to do fewer sub operations, basically. Yeah, so you can see here, this took about 2.5 minutes. And then I was curious because that's a lot. There's a total of 6 constellations, and that's less than 1/6 of the time it took to load the full file. So I was curious what would happen if I loaded all constellations separately and then I merged them together myself. And it turns out it's a lot faster. It only took about 1/3 of the time just for this one file I tried. So that was kind of an indicator to me that maybe there was a way for the code to change kind of around that idea. And then it turns out that loading, just keeping the files for each constellation separate might actually be most logical for UNAPCO anyway. So here on the left, this is kind of a visual of what it would look like if you have all constellations in one file. And you can see like there's a lot of empty white space here, right? There's going to be a lot of space that's not containing data. And so when we think about cloud optimization, you don't really want a lot of empty space. You want to maximize space in the cloud because it costs money and time. And so when you store them all separately, like in the middle here, there's no leftover space. It's only a file per constellation. And then when you think about a lot of the use cases for this data, a lot of times scientists are only looking for data from a couple constellations. It's more likely it would be one constellation over multiple days. So it actually doesn't really inhibit the user at all to store the constellations separately like this. Yeah, so based on those profile results, as well as them corresponding with this cloud efficiency idea, my recommendations would be to stick with just loading constellations separately and speeding up that process because it's already so much faster. It does seem like when loading these constellations separately, potentially the whole file still has to be parsed. So there could be a way for GeoRhinex to be written such that this goes even faster than it is now. Another option is there are these optimization features. It's a parameter that's literally called fast for loading Rhinex 2 files that does not exist for Rhinex 3 yet. There's a note in the code for someone to create it, but it hasn't been done yet. So I think that that could also be something that UNAPCO could contribute. And I think it would speed up any type of loads, so those full loads as well as the separate constellation loads. So to finish my presentation, I just wanted to circle back to my goals and kind of talk about what I actually achieved. So I do think I was able to contribute to this larger cloud lift project. I am going to be leaving all the profiling data as well as a report I wrote, just kind of analyzing those results in case people don't want to go through the data themselves. On, I believe the UNAPCO GitLab is the plan for whoever wants to pick this up next. I'm hoping someone will. Yeah, and my hope is that I've left whoever the next person is with actual data to inform decisions. On the professional development side of my goals, I learned a lot about the GNSS domain. I own this textbook now, and I kind of read chapters of it throughout the summer, and Tim and I would talk about them. And it was really helpful for me just to get an idea of like why we need the data in these Rhinex files accessible, why scientists need it, what it's getting used for. And now I have this free resource in case I need it in the future. I also gained a lot of software development experience. So version control in GitLab was something that I wasn't super experienced with and is really essential for any job in software. Software performance optimization, which is the focus of my project, is also not something I felt like was really focused on in my undergrad. And so getting an opportunity to learn about cProfile, SnakeViz, these software tools was really helpful for me. And I'm glad I have that in the back of my head in case I need it in the future. And then also Python skills. So I learned I'd never used X-Ray before the summer, kind of just sharpening my coding skills through reading code, writing my own scripts to do these various things throughout the summer was, I think, really helpful. And lastly, I had the opportunity to do some of that career exploration I talked about. So Tim was really great in facilitating me attending various meetings that might be kind of career interesting to me. So he introduced me to Pangeo. We went to one of their meetings and also helped me go to the USIP summer meeting, which both of those are kind of data science for the earth sciences communities. And so now I'm on their mailing list. I got to go to some talks, just kind of see various ways in which people with my skills are working in earth sciences. So that was really great to see. And then lastly, our career circles. I think it was really cool to see just the various things that people are doing in geosciences and get a little more about their personal experiences and their careers as well. I think that's really helpful as a 22-year-old in STEM. Yeah, so I just want to finish up by saying some thank yous. I want to thank NSF for funding my project. I want to thank UNAVCO for facilitating this internship experience for me and for all the other interns. It was really great. I especially want to thank Tim for being a really wonderful mentor this summer. And I want to thank Anika and Kelsey for being incredibly supportive and available for myself and the other interns throughout the entire summer. Yeah, and I want to thank you all for listening to my presentation.
Great job, Jordan. Looks like Glenn has a question.
Mm-hmm.
Glenn, you can unmute yourself and ask.
Unmute. Hi, great presentation. Can you hear me now, Anika?
Yes.
Okay, sorry, I was fumbling through the unmute process.
It happens.
I guess I'm interested in how this is going to interface with some of the other tools that support our community, including our data archive interface development, because then we have to do the inverse problem. So you've been working on optimizing and understanding some of the issues related to loading these Rhinex 2 and 3 files up to the cloud. What about bringing them back out of the cloud for users to process? Because at this time, I don't think we have any capability from the widely used processing systems to use the native formats that you're putting into the cloud. So I know it's a big, broad question, but maybe you or Tim could just inform me a little bit on where we are about getting the stuff back out of the cloud for use in processing.
Yeah, I can try and then I can defer to Tim. My understanding is that these net CDF files are analysis ready and that maybe the tools aren't developed, but that they are pretty easy to work with once in the cloud. I'm not sure about what's been developed to kind of facilitate that. So maybe I'll have to defer to Tim there.
Yeah, Jordan, can you hear me?
I can.
All right. Hey, Glenn, I think it's going to be like a lot of these things. I think the hope is a somewhat iterative process where we recognize that, of course, we're not going to overnight shift an entire community away from Rhinex. So we'll have to continue to support that on the front end. But I think underneath it all, we have to efficiently store this in a way in the cloud. And what we really want to do is try to continue to create things like some of the notebooks that were mentioned in previous demonstrations that could encourage users to access the data in the cloud directly and sort of curate their own data sets and pull those down again through some web service. They could get the data in NetCDF or whatever version of cloud optimized data this ends up being internally represented as, but they could also locally download a Rhinex file. So I don't know if that, it's sort of going to be an iterative process, I guess, is the result.
Yeah, but I guess my question, Tim, is I figured that would be the case. And ultimately, one would hope that the development team at JPL will support the NetCDF format directly for ingest of various Constellation data. But they don't right now, unless I'm mistaken. And I don't think Gamut Glob K does either. So that means you have to do the inverse of this problem, which is take the now cloud optimized NetCDF Constellation files and put them back into either separate Rhinex files or a merged Rhinex file. So are we also working on that process too? And does it face the same problems as the upload side of this?
I think we are, if I can speak to what I think I know, is that we're addressing the first problem first and the next problem next. But I think that the intuition is that the reverse will be much more straightforward. The biggest challenge right now is designing this data model that's efficient in the cloud, and mapping that into an existing data model should not be that costly.
Okay, thanks a lot.
But we can talk about it more if you like, anytime.
Well, I think this is an important issue that needs to be dealt with as we move forward this way, because our analysis team, our analysis centers have to get all of the data every single day from all of our stations, right? So this is going to be something that we need to know where we are, and maybe have you join the analysis center working group.
Yeah, completely. And I think that's something, we put this on their radar, Glenn, and honestly, while they recognize the development they need to do to change that ingest, they're excited because of the amount of time it takes for their systems to read through text files. So they see the value as well. It's just a matter of the development. So,
okay, thank you, Tim, and thank you, Jordan.
Yeah, thank you for your question.